Craig Colts, welcome back to the YouTube channel. Today, distributive property, clearing up the fog on that. I know we've been struggling a little bit on this, and I don't know how else to explain it. Maybe this opportunity for us to take the extremely long approach will help in this. There's a lot of properties involved, and the basic facts is distributive property is simply factoring out the little pieces. So I'm going to give you another video here shortly on prime factorization so that you can understand how we get all the pieces of this stuff. Got to remember to look at the camera and not at myself. I'm being kind of narcissistic right now. Narcissism is a word that you guys need to look up in the dictionary if you don't know it. Speaking of narcissism, about me, I am wearing my uniform for Civil Air Patrol today. All those brochures and everything I tell you about that I do now that I'm out of the military to try to feel like I'm still in the military. I get to wear my stripes. I get all these cool patches, and then we've got our squadron patch right down here. So I spent Tuesday with my daughter out, and we were marching around, and we played some cool games, basically leadership type stuff. A lot of fun. Enjoyed it. But moving on, distributive property. So the distributive property is basically saying that through multiplication, and I don't remember the exact words of it, but essentially what we're saying is that the sum multiplied by a number is the same thing as the number times each factor added together. Okay, so let's take another look at this and let's just look at it step by step. So if we look at Pemdas, remember we have parentheses, then we have exponents, and then we have our multiplication and division, followed by some addition and subtraction, right? Now, let's look at our parentheses. So the parentheses we're going to do first. We're going to do the parentheses first. So 3 plus 4, and I keep hitting the wrong button. 3 plus 4 is 7. Okay. And now our next step are exponents. We don't have any exponents, so we're going to go to multiplication. Multiplication, m times d, or m and d, so we have 2 times 7. 2 times 7 is 14. Well, let's see if this holds true. We have no parentheses on this side at all, so we're going to go straight to our multiplication. 2 times 3 is 6. 2 times 4 is 8. So we still have our addition, and 6 plus 8 is 14. Well, remember today we said that it is a balanced equation and a solution when both sides equal the same thing. 14 does in fact equal 14. So what we have just done is proven the distributive factor works when we know the numbers. The distributive property works when we know the numbers. But what if we don't know the numbers? And there. I promise I will get much quicker and faster at this once we practice a little bit. Okay, so what if we don't know the numbers? Let's say we have to put an x into it because we just don't know anything. Well, with the distributive property, what we are saying is that it's okay that we don't know this x because we can still multiply by the factor of the x and distribute this 2 inside those parentheses. So what we get is 2 times x plus 2 times 4. And that is distributing the 2 throughout that equation. Why is that a good thing, you ask? Well, because whenever I distribute this, I can go on ahead and do the rest of it. Well, 2x is still going to be 2x, but 2 times 4, I actually know that. That's going to be an 8. So an equivalent expression to 2x plus 4 is 2x plus 8. And now I understand why would I ever want to do this? Well, right now it doesn't make sense, and right now this seems like a futile effort that provides you zero rewards. But what I promise is that we are doing what's called scaffolding. We are building our skills one level at a time to learn more complicated stuff as we go. And my pen is doing goofy stuff. There we go. So this will become extremely valuable when we get into our next steps and we start trying to solve for what x actually means. Okay, so let's try this one other step. We're going to go one more slide and then I will leave you for the night. Cursor, next slide. Okay, so 6x plus 3x equals 21. Well, let's break this down. It keeps switching to eraser. Okay, so this is actually 6 times x plus 3 times x equals, well, we can pull out the 6 even further, can't we? So we could say 2 times 3 times x plus 3 times x equals. And now with the distributive property, I can look and I can say, what do I have of both of these that's the same? Well, I have a 3 and a 3, and I have an x and an x. So using the distributive property, I could factor those out. Now, an important thing to remember with the distributive property is you never actually eliminate something. There's always a hidden 1 there. All right, so let's try and factor these out. If I can quit selecting my eraser, that would be wonderful. Boom. All right, so we're going to pull the 3 out, and we're going to pull that x out. So we've got 3x times, and now we've got this 2. Where's the y? There we go. This 2 goes here, plus, and now like I said, this 3 times x, there's still a 1 here. There's the understood 1. So 2 plus 1. So now I'm going to go on ahead and I can do my parentheses, and I'll wind up with 3x times 3 equals 21. Well, with the commutative property, and I'm out of space, with the commutative property, can't I rewrite that to be 3 times x? And if that's the case, I can go on ahead and do 3 times 3, which gives me 9x. Well, we just used the distributive property 9x to define what we've been doing earlier with combining like terms. If the variable and the exponent are the same, you can add the coefficients. Coefficients are the numbers we're multiplying by our variable. And once you have those coefficients added, you have your addition problem. Hopefully this makes sense. If you're more confused, remember, there is tutoring every morning, 7:15 to 8:15. Make sure you let me know to expect you. That way I can make sure there's a pass in the box at the front office. Good luck, and hope everything works out for you.